So guys, this will be the first of two videos that focus on making equations from graphs of exponential functions. I do want to say before we get into the video that all of the graphs that I created in this video, they were created through Desmos. So I do want to make sure that I give that credit to Desmos, that was the calculator that powered these graphs. So let's go ahead and get started. So a couple of things to keep in mind. A graph shows exponential growth if the curve looks like this, and it shows decay if the graph looks like this. All right, so think of it as start at the left. As you start at the left part of the graph and go to the right, is the arrow going up or down? If the arrow is going up, then the graph is showing exponential growth. If it's going down, it is showing exponential decay. Now, if the graph is showing growth, that means your b value, the number that has the exponent, has to be greater than 1. If the graph is showing decay, then that b value has to be between 0 and 1. If it helps you, you can think about it as being just less than 1, but it's really going to be between 0 and 1. A couple other things to remember. One is what happens to y as x gets bigger, all right? If as your x values get bigger, the y values also get bigger, then the graph is showing exponential growth. If as the x values get bigger, the y values get smaller, the graph is showing exponential decay. And the last thing here, guys, is you really only need 2 points to make your equation, okay? You really would like to have more, just because the more points you have, the more points you check, the more likely you are to create the equation correctly. But really, you only need 2 to make your equation, okay? And one other thing that I'll add here is the rules or the guidelines that we followed for making equations from tables, they still apply here, okay? For example, when you make your equation, that b value has to be made based on multiplication, okay? So let's do a few examples here. So on this example, as the x values are getting bigger, so as we go out to the right, the graph is going up, okay? That means this graph is showing exponential growth. So your b value has to be greater than 1. So when you go to make the equation from a graph, the first thing that you need to find, guys, is your y-intercept. So here's your y-intercept at 1, okay? So y-intercept is 1. Let's go ahead and write that down. So a equals 1. Then what you want to do is find other points, okay, preferably one right after the other, that they fall exactly on a point, okay? So what I mean by that is not a point like this one here, because it's kind of in the middle. To get to that point, you would go out 1.5, okay, and then go up 3. You don't want to do that. You don't want any halves. You want to just go over 1 up 2, okay? No decimals or fractions, if at all possible, okay? So let me get that point to go away. There we go. So we have another point right here. And then let's find at least one more. So the next point that we've got is this one here. And just so we're clear on how this is going, we'll take one more point right here. Okay, so look at your points there, guys, okay? So that first point, our y-intercept, is at 0, 1. Our second point is at 1, 2. Our third point is at 2, 4. And then our third point is at 3, 8, okay? Notice the x values are changing by 1, okay? What are the y values changing by? In an exponential function, they're changing by multiplication. So you've got to think, 1 times what is 2? Well, 1 times 2. 2 times what is 4? Times 2. 4 times what is 8? Times 2. So the y values are being multiplied by 2 each time. That means that your b value has to equal 2. So your equation for this graph is y equals 1 times 2 to the x power. But if a y-intercept is 1, we're multiplying by 1, that's not going to change anything. So we really can just drop the parentheses and the 1, and our equation will be y equals 2 to the x power, okay? So let's do a couple more, all right? But before we do that, actually, guys, once you come up with these coordinates like this, if it helps you, you can always rewrite them in a table, all right? If having that structure like that helps you make better sense of this, then that's perfectly fine. Just make sure that when you make your table that you write down all your points correctly, okay? All right, let's do another one. So this graph is showing exponential decay, all right? Because as the x values are getting bigger, the arrow is going down, the graph is going down. So find your y-intercept first. So our y-intercept is 1. Y-intercept is 1. Then normally what you're going to want to do, guys, is if the graph is showing exponential decay, you probably are going to want to go back here to find your other points, all right? So if we start looking back to the left of the y-axis, here's a point. If I can ever get this pen to work. There we go. So there's a point. And then let's see if we can find another point here. So we've got another one that might be a little hard to see, but we do have another point here at 9. All right. So we know that our y-intercept is 1. So then we need our b value. So let's write down these coordinates here, guys. So our y-intercept is at 0, 1. And then this point here is at -1, 3. Now, because this is showing decay, remember the b value has to be less than 1, all right? And we have to write it in terms of multiplication. So we only need 2 points to figure this out. So think you're going from -1 to 0 on the x's, so those are changing by 1, which is good. Then you've got to think from 3 to 1. What do you do to 3 to go to 1? What do you divide by? Well, you divide by 3. Or, instead of dividing by 3, think of it as multiplying by 1/3, okay? If we use our third point up here as well, which is at -2, 9, okay, we would see the same thing. 9 divided by 3 gives us 3, and 3 divided by 3 took us down to that 1. So the y values are dividing by 3 each time or multiplying by 1/3. So our equation then will be y equals 1 times 1/3 to the x power, but we would drop the 1 just because multiplying by 1 isn't going to change anything. So we'll have y equals 1/3 to the x power, okay? So that'll be our that's going to be it for the first video, guys, all right? And there will be a second video where we do a couple more examples as well as some that are a little bit more challenging.